Welcome to this today's session. In today's class, we are going to learn about the pultrusion in composite manufacturing methods. What is a pultrusion? Pultrusion is a continuous automated manufacturing process which is used to create a constant cross-section composite profile, such as rods, beams, channels, and tubes. The word pultrusion is derived from pull and extrusion. So you're hiding the key feature of the process, pulling fibers through a resin bath and heated dye. Once again, I'm telling that the word pultrusion is derived from pull and extrusion. So that the feature is pulling fibers through a resin bath and a heated dye to form strong, lightweight, and corrosion resistant structural components. It is widely used in applications where traditional materials like steel or aluminum are too heavy, corrode easily, or lack of tailored performance characteristics required for specific structural demands. Pultruded composites are commonly found in industries such as construction, aerospace, transportation, electrical, and marine. Then we should know the basic principle behind that. Pultrusion involves pulling continuous fiber reinforcements like glass or carbon fibers through a liquid resin bath to impregnate them. Uh, then the impregnated fibers are guided through the preforming guide and subsequently pulled into a heated dye, which shapes and cures the resin impregnated fibers into a solid composite profile. This method is an ideal for producing long parts with uniform cross section and high mechanical properties. Then, what are the processes in this? The processes are fiber feeding, resin impregnation, performing, heating dye, that means curing, and pulling mechanism, cutting, and these are the processes are there in during this pultrusion process. In fiber feeding, fibers are supplied from creels holding spools of continuous rovings. Example for this is glass carbon aramid. Additional fibers forms like mats or fabrics may be added to increase the transverse strength to our surface finish. And the resin impregnation. The fiber bundle is passed through a resin bath where it is saturated with the thermosetting resins, epoxy polyester, vinyl ester resins. Catalysts, color pigments, fillers, and fire retardants may be added to the resin to enhance the properties. Then performance, that means performing stations. The wet fiber bundle is guided through performing stations or shaping tools to align and compress it into the rough profile of the final sheet. The next one is heated dye, that is called curing. The impregnated fibers enter a heated steel dye where the resin undergoes polymerization, that is curing, due to the elevated temperatures. The shape of the dye defines the final cross section of the pot. Curing temperature typically ranges from 120 degrees Celsius to 180 degrees Celsius depending on the resin type. Next one is the pulling mechanism. It is a set of pulling clamps or caterpillar pullers. Maintain the tension and withdraw the cured composite through the die and down the production line. Finally, cutting. It is a cutting shop, often automated. The cuts of the continuous profile into a desired length. Next, we can see the materials used in the pultrusion in composite techniques. One is the fiber reinforcements. In fiber reinforcements, glass fibers are used, carbon fibers, aramid fibers, basalt or natural fibers are used. Already we have seen what is the glass fiber. Very common, cost-effective, corrosion-resistant. Carbon fiber, it is a high stiffness and a high strength material. It is very much used in the aerospace and high-end applications. Aramid fibers of the Kevlar, high impact resistance strength and having high toughness. Finally, the natural fibers, it is a very eco-friendly alternative with other users, specific users. Next, the metals used in the resins are matrix or polyester resin. It is very low cost but a good general purpose resin. Vinyl ester is superior chemical resistance and strength. Epoxy is an excellent mechanical properties as well as low shrinkages. Phenolic is a fire and heat resistant material which is used in the electrical applications. Finally, additives. That means fire retardants, UV stabilizers, colorants, filters for enhanced properties. So these are the additives are used here. And what are the different types of pultrusion? One is open bath pultrusion, injection pultrusion, then pulfoaming. In open bath pultrusion, fibers passes through the open resin bath. As well as it is very simple and cost effective. As well as it is higher chances of resin spillage or air entrapment. In injection pultrusion, the fibers are impregnated in a closed resin injection chamber. It's a cleaner, better resin control, and are ideal for automation. In pulfoaming, a variation of pultrusion that allows the cold or tapered shapes, and it combines the pultrusion with compression molding. Then advantages of the pultrusion are a high strength to weight ratio, continuous production, labor, it means a low labor cost, dimensional stability achieved here, corrosion resistance also there, design flexibility. So these are the advantages of pultrusion, as well as the limitations of the pultrusions are, one is limited to constant cross sections, as well as the initial die cost is high, and it is not ideal for complex geometries. Only thermoset resins are used here. Thermoplastic pultrusion is not at all here. So limitations of pultrusions are given here now, limited to constant cross section. As well as the die cost, the initial die cost is high. It is not ideal for complex geometries. Only thermoset resins are used here typically. Okay, so that's all in today's class. We can have another comparison also here for composite manufacturing methods with respect to the pultrusion, filament winding, hand layup method, resin transfer molding. We can see in the next class. Up to this, we can wind up today. We will see the other things in the next class. Thank you for your kind participation here. Thank you.